Okay, let's try 14.19. The position of a 50-gram oscillating mass is given by x of t is equal to 2 centimeters times cosine of 10t, where t is in seconds. Determine the amplitude, the period, the spring constant, the maximum speed, the total energy, and the velocity at 0.4 seconds. Okay, so this is going to be a lot of filling in with the equations that we learned in this chapter. And so let's go ahead and write the general form of this displacement equation. And so we know that x of t is equal to the amplitude times the cosine of 2 pi f times t. And so that's just the general form of this displacement equation up here. And so in part A, we're asked for the amplitude, so that's easy enough. Just comparing here, we can see that the amplitude is 2 centimeters. So it's 2 centimeters. Part B, we're asked for the period. And so we know that there's a relationship between the period and the frequency, and we know that the frequency is equal to 1 over the period. And so if we look over here, this can be written as the inside over here. 2 pi f can also be written as 2 pi over t, right? Because f is just 1 over t, so I'm just essentially filling in right here. And we also know that this inside right here is equal to 10, which has units of 1 over seconds. And so rearranging and solving for t, we get t is equal to 2 pi over 10, which has units of 1 over seconds. And this is equal to 0.63 seconds. And so that's the period. So let's try the spring constant, c. For the spring constant, we know that there's a relationship between the frequency and the constant, and f is equal to 1 over 2 pi times the square root of k over m. Now, in order to stay in the right units, we want to change 50 grams because we want to fill in the mass right here, right? So 50 grams, let's write it over here, actually save some space. 50 grams is equal to 0.05 kilograms. Okay, so now back to over here, back to the spring constant we're trying to find. So we're trying to solve for k, which is the spring constant. So if you notice, if we multiply 2 pi to both sides, we get 2 pi f, which is the inside of this equation, which is 10. And so let's go ahead and do that. So 2 pi f is equal to square root of k over m. And we know that 2 pi f is equal to 10, right? That's just inside. And so this is equal to 10. And so if we square both sides and multiply m to both sides, we get k is equal to 10 squared. And this 10 is going to have units of 1 over seconds again. So 10 squared times m, which is 0.05 kilograms. And this comes out to 5 newtons per meter. And so that's the spring constant, which makes sense, right? The more you stretch out the spring, the harder it is going to be to stretch. Okay, and now let's do D. We're looking for the maximum speed, and if you remember, our maximum speed and there has a relationship to the frequency and the amplitude, and so Vmax is equal to 2 pi times the frequency times the amplitude. And again, we know 2 pi f is just 10. That's just inside again, so 10, which has units of 1 over seconds, times the amplitude, which is just 2 centimeters. And so this just comes out to 20 centimeters per second. And so that's going to be our maximum speed. So now let's do the total energy. So if you remember our equation for energy, energy is just equal to 1/2 times the spring constant times the amplitude squared. And so we know all these again, so it's just equal to 1/2 times the spring constant, which is 5 Newton per meter, times the amplitude squared. So we want to keep it all in meters, so 2 centimeters is 0.02 meters. And this is going to be squared And when you plug this in your calculator, you get 1 times 10 to the negative 3 joules. Okay, so that's the total energy of the system. And so the last part, the velocity at t equals 0.40 seconds. And so if you remember the velocity equation, there's another color so it doesn't get too confusing. The velocity equation, v of t, is just equal to negative v max. So the max velocity, remember we solved for that already, right here, times the sine of 2 pi f times t. So if you notice, these both have the same guts, right? 2 pi f, 2 pi f. And so filling in, v of t is equal to negative v max, which is negative 20, times the sine of 2 pi f, which is just 10 again, times t, which is which in this problem is, what are we saying, 0.4 seconds, times 0.4 seconds. And so this should actually be 0.4 seconds as well, right? Because it's v of 0.4 seconds. And so then when you plug this all in your calculator, make sure it's in radians for this part over here, you get 15 centimeters per second. So this problem was mostly just a review of all the equations that we learned in this chapter, which was a lot of equations. So that's problem 14.19.